Okay, this is Mr. Peterson continuing with the review for Algebra 2, sections 7.1 through 7.6. And we're on problem 14. We're going to do through 19 in this installment. Okay, the first two problems here, 14 and 15, ask us to subtract if possible. And what you're looking for when you're subtracting or adding for that matter is like radicals. You have to have the same indices. These are both square roots instead of one being a square root and the other being a cube root. They have the same radicands, in this case 5 underneath both of them. And what you do is just combine them. So 8 minus 6 is 2. And the problem reads as follows. 8 root 5 minus 6 root 5 is 2 root 5. On the next problem, number 15, you'll notice that the radicands don't match. One has a square root with a 3 underneath it, and then the other has a square root with a 2 underneath it, and this is when you can't combine. So we just have to leave this one just like it is. Now you might think number 16 is the same type of problem, but what's going on here is that the square roots are hiding perfect squares. In other words, they're not simplified. So we're going to break the root 18 into root 9, root 2. You can see that that root 9 is a perfect square. We're going to do the same with the square root of 50. It breaks up into square root 25 times square root of 2. Once you've done that, I usually work down the left-hand side and simplify. And then I work down the other side and simplify. And once you get down to the bottom here, you see that, this problem was hiding like radicals. They both have square root of 2 in them. So now you just combine them. And this problem ends up with 39 root 2 as its simplified answer. Okay, moving on to problem 17. In problem 17, we're supposed to multiply these two binomial expressions. Now, we usually use FOIL on this. First times first, outside times outside, inside times inside, and last times last. What I'm going to do is a little bit of a rearrangement of that. I'm going to do the first and the last to start. So right here you get 30. And on the last times last, you get negative 12 square root of 4. Notice that when you're multiplying, unlike adding and subtracting, the radicands don't have to match, and they'll change. So square root of 2, square root of 2, now it's square root of 4. Then you have the outside pair, which is 20 root 2. And you have the inside pair, which is minus 18 root 2. We'll combine those later because they're like radicals. All right, the 30 stays just like it is. If you take that second term there, 12 times root 4, the root 4 is just 2. So 12 times 2 is 24. And then I took the 20 root 2 minus 18 root 2 to get the 2 root 2. One more simplification, and we're home free. Okay, on problem 18, you have a binomial that's being squared. Resist the temptation just to square both parts of it. You have to write it out twice and then FOIL it, or I prefer first, last, outer, inner instead of the typical order. And you can then combine your like terms and get your answer. Okay, number 19 just has one little curveball. This is a very simple problem. You're just trying to subtract root 6 from 12 root 6. And if you'll think of that second term as having a 1 in front of it, it makes it a little bit easier to see this. But you're just going to say 12 root 6 minus 1 root 6, which is 11 root 6. So that does it for, let me see, is there any more here? I'll do those later. Okay, that does it through problem 19, and I'll continue on the next video with problem 20.